Hey friends, welcome back to the channel and to the 8th episode of Research Paper Summary. Today I'll be covering an ACL 2020 paper, a re-evaluation of knowledge graph completion methods. This paper shows that recent state-of-the-art knowledge graph completion models has been evaluated incorrectly, and as a result, they reported extremely high inflated performance results. To alleviate this problem, the paper has proposed a new simple and robust evaluation protocol for any future knowledge graph completion evaluation. In this video, I will first briefly cover the context and contribution of this paper. I will then dive into what problems are currently causing this inaccuracy in knowledge graph completion evaluation methods. After that, I will cover the new evaluation protocol that were introduced in this paper to alleviate this problem. And lastly, I will finish up this video by sharing some of the experimental results and analysis. I hope you find this video useful. Let's get to it. If you're new here, my name is Ryan. I'm a first year PhD student based in London, and on this channel we share actionable insights on different topics in AI research, entrepreneurship and life design, encouraging us to take more action and live a happier and more intentional life. If these topics are interesting to you, consider subscribing. Knowledge graphs are usually used to represent factual knowledge of the world. However, as you can imagine, it's impossible for a single knowledge graph to capture every single fact in this world, and so in most cases, knowledge graphs are incomplete. Knowledge graph completion aims to predict missing links and facts in large knowledge graphs. Knowledge graph completion usually falls under two groups: translation-based methods and semantic matching methods. Recently, just like any other NLP task, neural network methods has gained large popularity simply because they are able to yield strong performance results. However, this paper has found that although many recent state-of-the-art models have shown high performance results, many of these improvements are not consistent across different benchmark datasets. Here we have conv as the benchmark model and Freebase and WorkNet as the popular benchmark datasets. For few neural network-based methods, there are inconsistent gains on these two datasets. For example, conv-KB and CAPS-E both reported significant improvement over conv-E in the Freebase dataset, but shown decreasing performance in the WorkNet dataset, which is surprising. On the other hand, both Rotate and Tucker showed consistent results across both benchmark datasets, which is what you would expect from fundamentally strong models. This paper has two main contributions. First, they found out that the performance of recent state-of-the-art models were inflated due to inappropriate evaluation protocols. Second, they proposed a new simple and robust evaluation protocol to fairly evaluate future knowledge graph completion models. Let's now dive deeper into what is causing this inaccuracy in knowledge graph completion evaluation. Since every instance in the knowledge graph is a positive sample, knowledge graph completion usually requires negative sampling to generate negative samples in order to train the model. Having said that, what the paper found unusual is the score distribution, where some negatively sampled triplet has the same exact score as the valid triplets. This figure here shows the score distribution of conv-KB for one sample valid triplet and its negative samples. Out of the 14,541 negatively sampled triplets for this one valid triplet, 8,520 of them have the exact same score as the valid triplet, which is very unusual. Zooming out to the entire dataset, the figure here shows the number of triplets with the exact same score over the entire dataset. We compare conv-KB and CAPS-E against the conv-E model. As you can see here, we found that conv-KB and CAPS-E has multiple levels of unusual score distribution, whereas conv-E clearly doesn't have this problem. So what's causing this unusual score distribution? Turns out this unusual score distribution can be explained by the high ratio of neurons turning 0 after applying ReLU activation function. As you can see here, we found that in conv-KB and CAPS-E, 87.3% and 92.2% of neurons become zeros after applying the ReLU activation. This is very high compared to conv-E level at 41.1%. Because of this zeroing, the representation of triplets become very similar during training, and that's why it leads to very similar, if not the exact same score, between valid triplet and negatively sampled triplet. Now that we have a better understanding of the underlying problem, what can we do to fix this so that we can better evaluate knowledge graph completion models in the future? Well, this paper has proposed a new general evaluation scheme for knowledge graph completion with 3 different protocols. First, we have the top protocol, where the correct triplet is placed at the beginning of the candidate set. Given the correct triplet is always at the top of the ranked list, top evaluation protocol does not evaluate model that gives different triplets the same score rigorously. Next, we have the bottom evaluation protocol, where the correct triplet is placed at the end of the candidate set. Here, the bottom evaluation protocol has the opposite effect compared to the top evaluation protocol and is seen as unfair to the same model given that the correct triplet is always ranked the lowest. Lastly, we have the random evaluation protocol, where the correct triplet is placed randomly in the candidate set. Random evaluation protocol is seen as the best one as it evaluates the model fairly and rigorously. Let's now dive into the experimental results. In terms of the experiment setup, we have categorized different knowledge graph completion methods into two groups. Firstly, we have the non-affected knowledge graph completion methods. Here we have COV-E, rotate, and tucker. Secondly, we have the affected knowledge graph completion methods. Here we have COV-KB, CAPS-E, and KBAT. The evaluation metrics for knowledge graph completion are the classic mean reciprocal rank, MRR, mean rank, MR, and hits at 10, all on filter settings. Here are the results. Here we are comparing the reported performance of different knowledge graph completion models against the 3 evaluation protocols that were introduced in this paper, with random being the most reliable metric. As you can see here, the non-affected methods, COV-E, rotate, and tucker, their performance are consistent across the different evaluation protocols. However, with the affected methods, there is a big variation in performance across the evaluation protocols. These models perform the best when evaluated using the top protocol and the worst when evaluated using the bottom protocol. We found that the affected methods score a lot lower than their reported performance when evaluated using the random evaluation protocol, which highlights that these neural network models aren't evaluated properly. And that's it for today's video. If you like this video, be sure to subscribe as I'll be covering more research paper summary in future videos. In the meantime, feel free to check out other videos on my channel. Thank you for watching. I'll see you guys in my next video.